All right, so we come back section 6.1 here. We're going to talk about the standard deviation and variance of a discrete random variable. Now, since we use the mean as our measure of center, it shouldn't be too surprising that we would use standard deviation for our variability. So now here's what you have to do. You got to take each value and subtract the mean, square it, and then multiply it by the probability. Do that for each one, add them up, and then you're going to have to take the square root to find the standard deviation. Yeah, a little bit of a process here of what we have to do. So here's what we had earlier with those APGAR scores. We did find that the mean to be 8.128, okay, using mu, of course. And so here's our probability distribution. So what we're going to have to do is we're going to have to take, we're going to have to take 0 minus that mean, square it, and multiply it by its probability. Yeah, we're going to have to keep going here, and then have to keep going as we go for each one of those. 1 times, or 1 minus that squared times 0.006, so on and so forth. And then, of course, after that, we'd have to go ahead and take the square root of that. So we're getting our standard deviation of about 1.437 is what we get. And so what we're talking about is that a randomly selected score typically varies from the mean of 8.128 by about 1.437 units. Okay, a little tedious process, but you have to figure that out. Now, a continuous random variable can take on any value in an interval on the number line. So it's not just a discrete one, it's continuous here. And so the probability is going to be the area under the density curve and directly above the values on the horizontal axis that make up that event. All right, so if we had something like this, the probability if y is a randomly generated number between 0 and 9, and the shaded area represents the numbers 3 through 7 inclusive. Well, again, to find the probability of that, we'd have to find the area of that density curve and just figure that out. It's pretty easy, actually. So, all right, so here we go. Selena works at a bookstore in Denver International Airport. She takes the airport train from the main terminal to get to work each day. Now, the airport just opened a new walkway that would allow Selena to get from the main terminal to the bookstore in 4 minutes. Now, she wonders if it will be faster to walk or take the train to work. Now, y is Selena's journey time to work in minutes by train on a randomly selected day. Now, the probability distribution of y can be modeled by a uniform density curve on the interval from 2 to 5 minutes. Now, we want to find the probability that it will be quicker for Selena to take the train. So here's what she has: from 2 to 5, uniform density curve from 2 to 5. So that's 3, right? That's the length of 3, 2 to 5. So we know the height here has to be 1/3. So to find that probability, we find the length here, which of course is 2, times the third, which would be 2/3. Okay, so obviously we'd have a 0.66% chance of having just take less than 4 minutes of what we would say. All right, so again, chance that it's quicker for Selena to take the train to work on a randomly selected day. That's the probability of that happening. Okay, how about this one here? Now, the heights of young women can be modeled by a normal distribution. Okay, not uniform. This is the normal distribution. We're coming back to it. The mean is 64, which we can see right here. All right, and the standard deviation is 2.7 inches. Okay, so we mark 1, 2, 3 standard deviations above and below. Now, we want to know, suppose we choose a young woman at random. Let y be her height in inches. We want to know what's the probability of being between 68 and 70 inches. So we're going to be in between those two right there. All right, so now we have to go back. Remember our z-tables here. We have to figure out those z-scores, right? So we take the actual minus mean divided by the standard deviation. So for the 68-inch, that's the standard z-score of 1.48. The other z-score for 70 is going to be 2.22. So we go to our z-table and we can find those percentiles. All right, so 2.22 is 0.9868. 1.48 should correspond to 0.9306. The difference there being 0.0562. So that's how we could find that area under that curve. That's what we do using those z-scores. Now, you can use technology. Remember, you can go into that on the calculator, normal, CDF, and then go put the lower at 1.48. Still have to figure out your z-score. The upper is 2.22. Put a mean, a 0, and a standard deviation of 1, because that's a standardized score. Since we've already standardized the score, we can leave it like that, and it'll actually tell us the difference of the area under the curve there is 0.0562. Okay, so go through that. The tech video's there in case you forgot. You can always run through that and handle that. So again, that's what we're looking for those answers. All right, so the probability, again, answering the questions, the probability that a randomly selected young woman has a height between 68 and 70 inches is about 0.056. All right, so that concludes section 6.1. Again, all these different learning targets that we have, should be able to knock those off and look at some problems. Again, do the exercises that go along with the chapter. They really take the information we have here, give you practice in different settings, and through that you really, really do develop a good understanding of what's going on. So I encourage you to get at those. All right, with that, we'll see you next time. This is 6.1. So until next time, I'm Mr. Boone.